fine. So in this video we're going to discuss about angles in a circle or angles properties of a circle. So before we can start the properties of a circle, so we're going to discuss about the parts of a circle. So basically, what is circle? A circle is a set of points which equidistant from a center. Now the first part of a circle is a diameter. And what is diameter? Diameter is a distance across the width of the circle through the center. The second one is a radius. Radius is a distance from the center of a circle to the circumference. That's our radius. And after radius, we have a circumference. Circumference is a distance around outside the circle. So the next one, when we have a two radii, inside the two radii area is called a sector. Now in that case we have a two sectors. One is a minor sector, the second one is a major sector, and the arc of the minor sector is called a minor arc length, and the arc of the major sector is known as the major sector. The next one is where a line touching a 2 points of the circumference, a line segment with the two end points of a circle is called a chord, and area inside the chord we have a segment, and then we have a two segments over there. One is the minor segment and second one is the major segment. Last but not least, what is a tangent line? A line drawn at a right angle to the radius at the circumference is called a tangent line. So that's a few parts of a circle. That's quite important before we can start the angles inside a circle. Now we can start the first theorem or the first property, angles inside a circle. So theorem number one is angle subtended in a semicircle is a right angle. It means that if angle subtended by a semicircle is a right angle triangle. For example, that's my semicircle, half of a circle, and if I conduct or if I just draw any angle from this semicircle, it's make a 90 degree on the circumference. See, that's my 90 degree. The next one is if I draw like this, so you can observe that's my semicircle and it's obtained a right angle to the circumference. Now see the few example. Angles A is mentioned over there, angle 70 is given. We have to find out the angle A. Now the property angle by a semicircle, they always make a right angle to the circumference, so we assume our circumference angle is a 90 degree, and the properties of a triangle, the sum of the all angles inside a triangle is add up to the 180 degree. So if I subtract 70 and the 90 from a 180, so 180 minus 90 and the minus 70, so it contains 20. The next one is B is given, 45 is given, an angle by a semicircle. They always make a 90 degree on the circumference, so we subtract 90 and the 45 from 180, so my B angle is the 45 degree. Now in the third part you can observe our 130 angle is the exterior angle. So first we have to find out the interior angle. Now we can utilize the straight line property over there. So straight line is 180 degrees. So if I subtract 130 from a 180, it's a 50. So inside the angle is, or our interior angle is 50 degree. So now once again the angle by a semicircle, they always make a 90 degree to a circumference. So if I subtract 50 and a 90 from 180, it's make a 40. So C is equal to the 40 degree. The next one, X is given, 2X is given, and the angle by a semicircle, they always make a 90 degree on the circumference. So X plus 2X equal to 3X, and we subtract 90 from 180, it's 90, and divided by 3, it's make 30. So X is equal to 30. So now that's our first property, angle by a semicircle, they always make a 90 degree on the circumference. Now the second theorem or the second property, the second theorem is angle subtended by an arc at the center of a circle is twice that the angle on a circumference. That's a quite important property. The angle by an arc, the same arc over there, so twice at the center and a single on a circumference. Now see the example. For example, the red one is my arc. So this arc contains two angles, one at a center, second on a circumference. So central angle is a twice angle on the circumference. For example, if that angle is a, so central angle is a twice, means it's a 2a. This question be like this one. For example, this red one is my arc. So this 2a is my central angle and this a is my circumference angle. So we know the angle subtended by an arc, center is a twice of the circumference. So that's my center and that's my circumference and that's a twice of the circumference. Now, or be like this. Now in that case, this one is my arc and that's my center, that twice on the circumference. So your examiner, they should be asked question on the 3 point of view, the first one, the second one and the third one. Now see the few examples. Now if the central angle is 80, we have to find out the circumference angle, and we know the circumference angle is the central angle twice of the circumference angle. So we divided by 2 for the value of d. So 80 divided by 2, it's 40 degree. Now in the second part, we have to find the angle of E, and so 72 is a circumference angle, and if I multiply by 2, it's 144 because central angle is a twice of the circumference angle. Now the next one is F part. F part is a central angle is given over there. We have to find out the circumference angle, so divided by a 2. The next one, first we have to find out inside the angle, this one, because G is an exterior angle. Now 67 divided by a 2 is 33.5, and you can see this G is a straight line, and a straight line is a 180 degree. If I subtract 33.5 from 180, so it's 147.5. Now the last one, 96 is a circumference angle, and we have to find out the central angle. So 96 times by a 2 is 192. So 192 is my central angle. So that's a property number 2. If you can see, an angle subtended by an arc at the center of a circle is a twice at the circumference. Now the third property, and the easiest property, the opposite angle on the cyclic quadrilateral is supplementary. Now you can see what is cyclic. Cyclic means circle. Quadrilateral, a four-sided shape, a shape who contains the 4 vertices of 4 sides and the 4 angles is called a quadrilateral. And supplementary means if we can add 2 angles whose addition is 180 degree. Now see, we have a circle, and inside the circle we have a quadrilateral shape because it contains the 4 sides and the 4 vertex. A, B, C, D is the 4 angles over there, and this shape inside a circle. Now the property is when we add the opposite angle, for example A and the D, the sum of A and D is 180 degree, and if I add C plus B is once again is a 180 degree. Now see the few examples. For example, if 115 over there and 83 over there, first we have to find the value of I, because I, J is the 2 missing angles over there. So 83. So when we add I and 83 is add up on the 180 degree. So if I subtract 83 from 180 is 97. So my I angle is 97. The next one is J angle. Once again we subtract 115 from 180. So 115 subtract from 180, it's 65 degrees. So I is 97 and the J is 65. Now the second shape is we have a kite inside the circle because the property name is cyclic quadrilateral, means circle, and inside the circle we have a shape of quadrilateral. Now in that part 123 angle is given and K is the missing angle. So when we add these 2 angles whose addition is 180 degree. So if I subtract 123 from 180, so it's 57. So my K is 57. So now in the next part, L and M, the 2 missing angles, but when we add L and the M, as we know the angles, addition of the opposite angles are 180 degree. So each angle contains the 90 degree because the kite L is equal to M, and that they both are 180 degree. If I divide it by 2, so each contain the 90 degree. The fourth property is angles subtended by the same arc or the chord are equal. So if you can subtend, if you can draw any angle by the chord, they are equal. For example, like this, if this red one or the blue one is my arc and that's my chord, because chord is a line who touching the 2 points of a circle. So for example, if the blue and the red one is an arc over there, they have a same angle. For example, this y and the y have a same angle according to this blue arc. Okay, like this. These two angles are equal. Now, from these two angles are equal. So, angle by a same arc or the same chord are equal. If you can observe from the above side, if you can observe from the down side, so y equal to y and x is equal to x. And some student they call that's a Spider-Man eye, because it look like a eye of a Spider-Man. Now, the next one, you can solve a question regarding the same chord. Now, if the 15 over there and n is over there, according to the same chord, n is equal to 15, because angles subtended by the same chord and the same arc, they both are equal. Now, in that case, that angle is 43 and the p is missing over there. According to Spider-Man eyes, these both are equal. So, p is equal to the 43. The next one, in the q, if this is 37 and q is missing over there, according to the property, these both angles are same according to the same arc. So q is 37 and according to the r is 54. According to same property, angle by the same chord or a same arc. Now q is given, r is given, miss q is given over there, it's 37, 54 is given. We have to find the angle of s by the properties of a triangle when we add a two angle and subtract from 180. So now 180 minus 37 minus 54, it's make a 89. So that's the four properties: angle by a semicircle, angle by a same arc, angle by a cyclic quadrilateral, and angle by same arc or same chord. Now we can summarize. So angle by a semicircle like this, angle by the opposite angle of the cyclic quadrilateral is supplementary, angle by subtended by and same center or a same arc twice on the center and the single on a circumference, and last but not least, angle subtended by the same arc or a same chord, they both are equal. Now we can solve a more complex question. In that part you can see all the four properties will come at a time. Now first we can find out the angle of A. So A and the B and the C, three angles are missing over there. So now we can use the angles, and the first one, angle subtended by a semicircle. You can see the blue angle is over there and it's subtended by a semicircle. So it contains the 90 degree on the circumference. So in that case, our A angle is a 90 degree. Now the next part, the angle of B. So the angle of B is a cyclic quadrilateral, because A, B, D and E is a shape of quadrilateral. So the opposite angle is add up of the 180 degree. So B and a 64, if I add B and 64 equal to the 180. So if I subtract 64 from 180, so B is equal to 180 minus 64 is equal to 116. So B angle is given. So once again, for the angle of C, we can use once again the cyclic quadrilateral property, because in that case B, D, E and E is a supplementary angle. So we can subtract 116 from 180, so it's make a 64. The next question is, first of all we have to find out the angle of D. So the second property, angle subtended by an arc at the center of a circle is a twice on the circumference. So if you can see, that's my angle by center or a circumference. 65 is given. We have to find the angle of D. So angle of D, the central angle, is a twice of a circumference. So 65 times by 2, it's 130 degree. Now for the value of E, E angle by same arc, or we can say the same arc or same chord we can utilize over there, or we can use the same property, angle subtended by arc is twice. So 130 is given, so angle of E is half of 130. So we can use the both properties over there. Either you can use twice of the circumference, either you can use the angle subtended by same arc or the same chord, they both are equal. That's it.